Right now, billions of people are preparing to watch the FIFA World Cup. But what if some of the audience isn't from Earth? Every 4 years, the entire world gathers to watch the most popular sport on Earth, football. The FIFA World Cup, a one-month-long tournament, is observed by an estimated 5 billion viewers globally. Energy consumption, satellite communications, and broadcasts spike in a way that could perhaps be perceived by an alien civilization. So, are aliens watching the most beautiful sport in the world? Hello, Dr. Alejo here. The event that billions of people wait anxiously for 4 years is finally here. I am recording this on Monday, the 8th of June in Brisbane, Australia, which means that in less than a week, the ball will start rolling in the inaugural game of the FIFA World Cup 2026 tournament. The FIFA World Cup is without any doubt the most watched event on Earth, surpassing the Olympics and the Super Bowl. The 2022 final between France and Argentina was watched by over 1.5 billion people. Host countries invest billions of dollars in upgrading their telecommunication infrastructure, which includes new transmission antennas and satellite networks, increasing our technological footprint as a planet. So, the question is simple. Could aliens watch the World Cup and become aware of our existence? A recent SETI study tried to answer a surprising question. If another Earth-like civilization existed somewhere among the stars, how far away could they detect our technology? Technosignatures are evidence of some technology that modifies its environment in ways that are detectable. The first radio emission date from 1895, when Marconi conducted the first successful outdoor transmission of wireless Morse code over a distance of more than a kilometer. Initially, radio technology could only transmit sound, but in the late 1920s, scientists figured out how to transmit pictures and audio. In 1939, radio transmissions of TV became a reality. TV radio transmitters started broadcasting powerful radio signals in all directions, and millions of televisions tuned into those transmissions. Unlike sound, radio waves don't require a medium to be transmitted. So these transmissions didn't stop at Earth's atmosphere and continue to travel through the vacuum of space. This means that TV broadcasts are currently traveling through interstellar space. Given that they move at the speed of light and in all directions, we can imagine a sphere around Earth that every year expands by 1 light year. The 1970 World Cup broadcasts have now traveled approximately 56 light years. The 2022 World Cup broadcasts have traveled only about 4 light years. But being able to travel at the speed of light and get into other potential solar systems isn't the only requirement for an alien to be able to watch Maradona scoring his infamous goal in the 1986 final. When you broadcast in all directions, the signal strength falls with the square of the distance. So, by the time it reaches another star system, only a very small fraction of the original energy remains. By 56 light years, the signal could be almost indistinguishable from interstellar noise unless they have highly sensitive radio telescopes. TV transmitters were never designed for interstellar communication. Their purpose is to cover a city, a region, or even a country. So, the majority of the transmitted energy stays near Earth, and only a small fraction escapes into space. In addition, TV signals are broadband. This means that a TV signal spreads its power over a large frequency range. This is contrary to what SETI researchers search for, narrowband signals. In a narrowband signal, all the power is concentrated into a tiny frequency range, which helps with the tuning on the receiver's side. For a TV transmission, the power spreads across an entire channel, and the received signal is much weaker in every individual frequency band than if we concentrate all the power on a specific frequency. Even more, the technology we use to transmit TV broadcasts has actually made it worse for hypothetical aliens to detect one of those signals. In the 1970s, for instance, terrestrial TV towers were the main method for broadcast TV, but this has changed a lot. Today, Fiber optics dominate, and the use of internet streaming is widely spread. The internet around the world doesn't use that much radio communications anymore, but cables, which don't allow too much signal leakage. In addition, satellite links are highly directional. This means that, contrary to popular belief, satellite transmissions don't act like a giant beacon broadcasting into space. A good analogy is to imagine modern satellite transmissions more like a laser pointer than a light bulb. This means that almost all the energy of the transmissions goes directly from the ground station to the receiver satellite orbiting the Earth. So, an alien astronomer observing Earth today might actually have a harder time detecting our entertainment broadcasts than an alien astronomer observing Earth 50 years ago. But what if people watch YouTube videos or stream a World Cup match using their cellular data? What if they exchange texts arguing about who is the greatest of all time, Messi or Ronaldo? It's Messi, by the way. Then perhaps there is still some hope for aliens, especially if they are close by cosmic standards, of course. In their paper, Earth Detecting Earth, at what distance could Earth's constellation of technosignatures be detected with present-day technology, the authors conclude that signals transmitted using the cellular LTE technology could be detected as close as 4 light years. So, aliens could potentially detect the existence of LTE-based communication associated with human activity, including communications related to the World Cup. 4 light years is the distance at which the Proxima Centauri and Alpha Centauri A and B planetary systems are located. 2 rocky planets have been confirmed orbiting Proxima Centauri. But if this is not enough, and someone is really interested in aliens far, far away knowing about the World Cup, then they could transmit one of the games, I would choose the final for instance, using our Deep Space Network. The NASA Deep Space Network, or DSN, is the largest and most sensitive scientific telecommunication system in the world, responsible for communicating with and tracking interplanetary spacecraft. The DSN consists of 3 massive antenna complexes located in Goldstone, California, Madrid, Spain, and Canberra, Australia. The location of the complexes guarantees that as Earth rotates, at least one antenna is always on a direct line of sight contact with all the missions in space. For instance, these are the antennas that NASA uses to communicate with the Voyager's probes, which are currently at 23 light hours from Earth. The DSN enables communication with the rovers on Mars and with a multitude of missions. The DSN still uses our old friend radio technology, but the difference is that it employs huge dishes with up to 70 meters of diameter, the equivalent to a 20-story building laid on its side. The DSN also uses much higher effective radiated power. The authors of the paper estimated that transmissions using the DSN could be detected out to approximately 65 light years. A sphere with a radius of 65 light years contains thousands of stars, hundreds of known exoplanets, and many potentially habitable worlds. So, some engineer with a lot of time on their hands could decide to transmit a game using the DSN. For very distant spacecraft like Voyager, data rates can be extremely low, sometimes only hundreds of bits per second, but the DSN can support much higher data rates for closer missions, such as a spacecraft around Mars. So, transmitting a live football match would be technically possible in principle, but it would require the right transmitter, enough bandwidth, and a very carefully designed communication link. But if you really want to go nuts and reach very, very far away aliens, then you will use our planetary radar technology. One of the most important tools astronomers have is our planetary radar capability. This technology uses extremely powerful transmitters to send radio waves to targets such as asteroids, comets, planets, or moons. These radio waves will reflect and be collected to determine different properties for the targets such as distance, velocity, rotation rate, shape, and surface properties. The most powerful radio transmitter ever built for astronomy was located in the Arecibo Observatory. This setup allowed astronomers to measure Mercury's true rotation rate, discover water ice at Mercury's pole, map Venus through its thick clouds, and discover lava flows on the moon, among other things. Unfortunately, the Arecibo observatory collapsed in December 2020, and no budget was allocated for its restoration. Perhaps the most important contribution of the Arecibo Observatory Planetary Radar Facility was to improve our planetary defense by helping to determine with extreme accuracy asteroids' distances and velocities, allowing scientists to refine orbit calculations and improve impact risk assessments, becoming one of humanity's most important tools for monitoring potentially hazardous asteroids. The authors of the paper estimated that aliens as far as 12,000 light years could detect the transmissions done by the Arecibo's planetary radar system. 12,000 light-year detection radius would encompass a huge fraction of the stars in our local region of the galaxy. This region contains millions of stars, including the TRAPPIST-1 system, located at 40 light-years, a system that contains several Earth-sized rocky planets located within the habitable zone of their home star. Unfortunately, if you had wanted to indeed transmit a football game using the planetary radar system of the Arecibo telescope, you would have to completely redesign the bandwidth modulation. The planetary radar was designed to transmit known code sequences consisting of zeros and ones. In this way, scientists could compare exactly what they sent and what they received after being reflected from the target. The comparison allowed those scientists to estimate the distance to the target, their velocities and shapes. Essentially, scientists didn't care about sharing information but optimizing codes to maximize precise comparison. On the contrary, transmitting a football match would require worrying about information throughput, as you need to send images and audio. In fact, scientists have already used planetary radar technology to intentionally send a message to the stars. The famous Arecibo message, part of an effort known as Messaging Extraterrestrial Intelligence, or METI, was sent in 1974 towards the globular cluster M13, located 25,000 light-years from Earth. The message was designed by astronomers Frank Drake and Carl Sagan and served as a symbolic demonstration of human technological capability. It contained numbers, DNA information, a human figure, a diagram of the solar system, and information about Arecibo itself. METI is highly controversial and the constant topic of many sci-fi stories and movies. We have a full video dedicated to METI, which I invite you to check out. So, there you go. It doesn't seem too feasible that aliens are right now watching some old FIFA World Cup tournament, or that they could watch the 2026 edition in a few years. However, it does look like humans are generating enough technosignatures to be detected by aliens at specific locations. The World Cup may not be visible across the galaxy, but the technologies we built to understand our solar system may already be announcing our existence to thousands of stars. So, next time you feel bad about yourself, think that there could be thousands of extraterrestrials out there that have never had the chance to watch Lionel Messi play football. In the meantime, come on Australia! Vamos Colombia! If you got up to this point, please consider subscribing to the channel and giving a like to this video. Do you have an opinion about humans being that visible in the universe? Perhaps other civilizations are more aware and decide to stay silent. Perhaps this explains why we don't hear from anyone. We explored this silence we observed in the video about the Fermi paradox. Thank you for watching and being part of this growing community. That's it for now, and remember, the truth is out there.